we're going to look at how to write an equation of an ellipse from the graph given. So first of all, we have to look at the ellipse, and we notice that it's a horizontal ellipse, and so therefore we're going to use this formula. The method will be then to find our h comma k, our center, and find these distances a and b. The distance c we can find. We don't need it for the equation, but we can find it so we can find the distance to the foci. So we look at the graph carefully, and this grid is a little bit small, and it's counting by halves. Each square is a half a unit, so it's a little bit hard to see. I know the screen is kind of small, but if we look really carefully at the coordinates there, that center has the coordinates negative 3, comma 1. So our h comma k is negative 3, comma 1, and we're going to place that into the formula, and so we'll have x minus negative 3, or x plus 3, quantity squared, and y minus 1, quantity squared. The next step is to find this distance a, this length. Well, again, since we have a graph of this, we're going to look at the numbers on the x-axes that correspond to the points, the center point, the x for that, and we're going to look at this vertex and look for the x at that, and we find that the distance is 7 units. So we write down the 7 for a, and we're going to replace that in the formula. So instead of a squared, we write 7 squared, which is, of course, 49. The next is to find our distance b, where our distance b is from the center to a vertex on the minor axes. And again, we look at the numbers on the number line, and we see that the distance is 4. And so now we're going to replace that b in the denominator with 4. So we have, instead of b squared, we have 4 squared, which is 16. And now we're done. The real question was, what's the equation for this ellipse? And here is the equation for the ellipse. So we've answered that question, but we might as well look at what is our c, what is the distance to the foci. And we know that to do that, we use the equation c squared equals a squared minus b squared, remembering that with an ellipse we subtract the two denominators. And so we have 49 minus 16, which is 33. And so this c, this distance for to the foci, is the square root of 33 units long. That length is the square root of 33. So to find this foci, we would do negative 3 minus the square root of 33, comma 1, and then to find the other foci right here, we would do negative 3 plus the square root of 33, comma 1. The next problem we want to do is we want to write the equation for the hyperbola that we have shown here. Again, we need to analyze whether or not this is a horizontal or a vertical hyperbola, and it is a horizontal hyperbola, so we have the formula written here where our h, it's positively h, so it starts with h, it's not positively x, excuse me, so it's x minus h quantity squared is what it begins with. The method is very similar to that of the ellipse. We need to find the center, and we need to find these lengths a, b, and c. Well, our center is right here in the graph, and we can look at the coordinate plane. We see that's the point 0, 0. So our h and our k are 0, 0. In the formula, we will replace the h and the k with 0 and 0. And of course, x minus 0 and y minus 0, we can just replace those with x squared and the y squared, since we're subtracting nothing, subtracting 0. The length a is on the major axes. Now in a hyperbola, the major axis does not mean the longest axes. It's the axis that goes to the vertex of the branch. So this is the vertex right here and the center. So this distance from the center to that vertex is going to be my A. So again, I look at the grid very carefully, and in this particular coordinate plane, each of the lines is 1 unit long, so that's 5 units from the center to the vertex. So my A is 5, and I'm going to replace that in the formula, and 5 squared is 25. For our B, I'm going on the minor axis, and again, the minor axis in this case actually happens to be longer than the major axis, but the minor axis is from the center to the side of the rectangle here. And again, we count the squares and we find that's 8 units long. So our b is 8. We replace the b squared in the formula for 8 squared, and then 8 squared is, of course, 64. So we have answered the question, what is the equation for the hyperbola shown? And here is the equation for the hyperbola. But we do notice that the foci has not been graphed in this picture, so let's go ahead and do that. We're going to do the graphing of the foci. And to find that distance c, recall that in a hyperbola, we're going to add the two denominators. It's a squared plus b squared. So we have 25 plus 64, which is 89, and so c is the square root of 89. Since we're going to graph it, we need to have the approximate. So the square root of 89 is approximately 9.4. And so in my graph, from the center, I'm going to go 9.4 units to the left and 9.4 units to the right. And when I do that, I will have the two foci in this hyperbola. So this is the end of the two problems that show you how to write equations of these conic sections when the graph has been given.